Hello, today's question is somewhat like this. A roller whose diameter is 1 meter. So we have a roller whose diameter is 1 meter, as you can see here. It weighs 360 newtons and we have to apply a horizontal force, as you can see here. Let me highlight this horizontal force necessary to roll it over a brick. You can see the brick here, brick 0.1 meter high, when force is applied at the center. So what we have to do here is we have to apply force like this, and we have to roll it over. So we have to roll it over by applying this sort of force. So let us write the given quantities here. So the given quantities will be somewhat like this. Let's write it here. Diameter of roller, I can name it as D, and that's equal to 1.0 meter. So that means radius of roller, I can say it as R, that should be equal to 0.5 meter. So in the diagram I have mentioned this is the diameter and this is the radius. So if radius is equal to 0.5 millimeter, then I have this BO should be equal to 0.5 meter, and also this OP should also equal be 0.5 meter. So that's why I can write here. So therefore I can write BO equal to, then OP is equal to 0.5 meters. So the weight of the body is 360 newtons. So I can write weight of body, which is W, that's equal to 360 Newton. Then we have to apply the horizontal force and find its value, and the thickness of the brick is 0.1 meter. So thickness of brick, let me write a symbol here, T, is equal to 0.1 meter. If so, then we have this OA, this AO will be equal to, so therefore AO will be equal to BO minus AB. So this AO should be equal to BO, this whole length minus this small thing, so minus AB, and that's equal to BO is equal to, just we have done, it is 0.5 meters minus this AB is equal to the thickness of the brick, so it is 0.1 meters, which is equal to 0.4 meters. So AO is equal to 0.4 meters. Now the only job remaining here is finding the value of this AP. So if I use this right angle triangle here, so if I consider this right angled triangle, so I can easily find the value of AP as well. So in a right angled triangle, triangle AOP, we should have AP should be equal to root of OP square minus AO square. That will be equal to, OP square is equal to, as you have seen here, 0.5 square minus, it is 0.4 square. So AO is equal to 0.4 like this, and as we know the Pythagorean triads, so it is 5, it is 4, then the other should be 3. So it should be equal to 0.3 meters. So AP equal to 0.3 meters. Now we apply here the principle of moments. So if we have to lift it over, we have to produce such a clockwise moment, which should be at least equal to the anti-clockwise moment, at least equal to or more than equal to. So that's why here let's write here, to lift the roller, the clockwise moment moment should be at least equal to the anti-clockwise moment. Anti-clockwise moment. So we must have here the clockwise moment is provided by the force F and the anti-clockwise moment is provided by the weight W. So that's why this should be equal to F into. So F into, this is the fulcrum, F into the perpendicular distance. So F into this perpendicular distance, and that's equal to, as you can see here, that's equal to AO. So F into AO should be equal to, next is a W. Since this is the fulcrum here, the perpendicular distance is equal to this. So this is equal to the perpendicular distance of this force W from the fulcrum. So that's equal to W into AP. So this gives us, or F into AO is just what we have done here, 0.4 equal to W is 360 into this is 0.3. So or F equal to 360 into 0.3 divided 0.4. So this point cancel out. 4, it should be 90 into that is equal to 270 Newton. So the force here required is 270 Newton, such that this thing just tips over or rolls over. So if it is more than 270, it will accelerate, it will roll and accelerate, and if it is slightly less than 270, it will again fall back to the ground.